Hi everyone and welcome back to the Offsite channel. Today we're going to be looking at value engineering tips for roof trusses. This is when you look to squeeze some margin out of your job. Could be that that's the standard way you do things, or the margin's a bit tight and you're looking to grab some back. So I want to say thank you to all of our new followers as well. Thank you very much for following us. It's very much appreciated. And I hope you enjoy the content. We have a new guest on the second podcast coming up at the start of June. It's Keith from HSB CAD, and he's going to be doing a presentation for us on design for manufacturing and assembly. So that'll be very interesting, and we look forward to seeing that presentation coming through. So today, like I said, we're going to be looking at truss value engineering tips, and I've got Chris Gould with me here, my wingman, and we're just going to go through and have a little bit of an explanation for each. So, first up, it would be beneficial to use stock lengths of timber to minimise waste. So, looking to reduce waste and burning timber for no reason, essentially. So, what we would look to do is use the stock length of timber, but obviously there's a bit of variance involved if you were just to use the standard stock length. So you want to cut about 25mm or an inch off the end of that, so you are sure that they are all the same length. But using stock lengths of timber is a good way to go, and it does and it should minimize time at the saw.
The next one we'd ask you to consider would be relating to using the combination of the joint, the node point for your splice and your joint combination. There are times where you can save quite a bit of square inch, especially when you have a bearing nearby. So consider matching that splice to that joint location.
Absolutely. Good tips. And obviously manufacturing time as well, when they're pressing, Chris, that there's one less node to press in the factory as well. So going through, we have the removal of the vertical. So your truss software is going to likely put a vertical web underneath the pitch break. And what I mean by a pitch break is a sloping rafter that meets a horizontal rafter on, like, say, a hip truss. So that's an example. However, you do get standard trusses with a horizontal and a sloping rafter combined. So anyway, remove that vertical web and put two diagonals coming together, meeting at that node point. That will reduce the need for the vertical web and plates. So you're saving on plates and timber in that instance.
Good stuff, Greg. Thanks. Next one we ask you to consider is on your heel ends. Consider reducing your web or increasing your web size to make for a smaller plate. Sometimes we use a 2x3 or a 3-inch web versus a 4-inch web on our attic room and on our heels, and it can reduce the amount of plate because we're putting more teeth into the web. And Absolutely. As we all know, steel is much more expensive than wood, so something else to consider.
Absolutely. Thanks, Chris. Another one for us is using site-specific loads. It is obviously good practice to do this anyway for your engineering sign-off, etc., etc. However, it also can have a beneficial effect on the analysis of the truss in the software, giving a benefit to timber section depths and plate sizes being reduced. However, watch out, this can also increase it if they are greater snow loads and wind loads than your default location setting. So it can work in your benefit, but it can also not work to your benefit. But you really should be doing that anyway.
Thanks, Greg. Another thing to consider is the ability to use a master truss. In other words, a truss that has already been optimized that we can take and use throughout the project to allow for the efficiency in the shop. Minimizing time spent on jig setup, so forth and so on, by utilizing a common piece, a common truss. It could reduce board lengths. There are times where it puts in an 8-foot web, for example.
Yeah.
We spend a couple extra minutes, we can get it down to an 8-foot. So, but doing that on every truss, maybe we want to create a master truss to use it from.
Absolutely. Also, I do remember, Chris, that we used to keep the trusses to the left, if you remember that rule. So the left hand of the table in the factory is kept the same, and the stub end varies on the right side. I remember you teaching me that rule as well, which is all very useful. Okay, another one is reducing the timber section size of the top hat or piggyback truss down to 3 inches or 4. Over here we would do it as 4 inches, Chris, on the piggyback top hat from the parent truss. So if you were to have a 200mm or an 8-inch rafter on like an attic truss below, not necessarily need that on the top hat piece. So reducing that timber size down obviously gives you a saving on timber cost on that as well.
Yeah, thanks, Greg. Also on that too, you could reduce the lumber grade to your minimum, your web grade, rather than a cord grade. The software does allow that. Next one to consider is where you've got a truss horn. In other words, where your joint comes together and you got that piece up, right? You got the height difference.
Yeah.
Consider reducing that down to your closest node or your closest joint. Or consider putting in a handling block. Sometimes what happens is that you get this cord depth. You don't need the cord the whole length. You only got to carry, say 8 foot of truss. You can save a lot of cost by doing something very simple like that.
Yeah, absolutely. So next we are on to looking at the whole roof system from the perspective of being mindful of how you design and how that will go into the shop, and then how the guys are actually going to erect it on site. If you design something really and you're focused on the design but not considering how it is then manufactured, and then how the guys are actually going to erect it on site, you should really be looking at the whole process, and that kind of goes into the DFMA side of things, Chris, is design for manufacturing assembly. So just be mindful that what you're doing in your design software affects manufacturing and the guys erecting it. So it's worthwhile noting that.
Good information, Greg. So finally for today, something else to consider, a bit unorthodox, I will say, but is the vertical in the floor truss really needed? The truss software plate manufacturers provide details that show how to attach webbing to receive a strong back. Sometimes you can get away with deleting a vertical at a chase, or even both verticals.
Right.
The consideration, can save you a lot of money, not only in plates and wood, but also in time. So personally, I don't do it if it changes grades.
Yeah.
But if it doesn't change grades on a 13-foot floor truss, you don't need any verticals in it except at the end. Something interesting.
Absolutely. So that was actually 10 tips there, Chris, that we did. 10 value engineering tips. So really looking to claw back some margin and keep the efficiencies run through design, through the shop, and on a site as well. So just as designers and technical, just be aware of what you do affects the whole process and not just what you're doing in the design office. So obviously, if you like these videos and you want more, then like and subscribe to them, share them with your colleagues if you find that they think any benefit of it. Leave your comments down below and we can discuss it further. If anyone else has any more tips they'd like to share with everyone, then we're all ears, aren't we? So be sure to check out our video podcast coming out in early June.
That's right, and I appreciate everybody's viewing. We do have a lot more in-depth stuff that we'll get to in the future. Today was really just some pretty basic things, but as time goes on, I think you'll be surprised with some of the tips that we can provide from a design standpoint.
Absolutely.
On both sides of the pond.
Yeah, absolutely. So again, guys, thanks for watching. and we hope to see you in the next video.